Welcome to Mastering Solutions. This problem can be a little bit tricky to set up, so let's start by drawing a picture and working our way through it slowly. So we have a thin film, of course, and we know that we're in air up here, which is going to be index of 1. And then this is our thin film. And so our thin film is magnesium fluoride, and that has an index of 1.38, and that's sitting on top of glass. So the glass will say its index of 1.50. As the light comes in, you probably see already we're going from low to high. So we'll have a phase change here, and then low to high we'll have another phase change here. Some light is reflected, of course. And so we have two phase changes. And then we want constructive interference because that's what they say they are observing with this glass. And so the equation that we'll be using with two phase changes and constructive interference is going to be 2t is equal to m lambda over n. Now we want the thinness of the film. So if we isolate t, that's going to give us t is equal to m lambda over 2n. And so this is the equation that we'll be using for this problem. Now, it's actually kind of a fun problem to work through. It's just tricky to set up to get there. But what we have to do is they say there's two wavelengths, and for both of those, we get constructive interference. And so for t, we're going to have the two wavelengths, m1 lambda 1 over 2n. Now, I don't mean the first order m for this. I'm just saying m1 so we can tell them apart, okay? We don't know what this m is. It could be 2, 3, 4, 5, whatever. And then we're going to have the same thing, m2 and whatever this m is, lambda 2 over 2n. So since they say there's constructive interference with these, the n isn't changing and the thickness isn't changing for any of them. So that's why we can set them equal to each other. And so really, we can say, let's just forget about the t here for a second. Let's just look at these two together. If we multiply now both sides of the equation here by 2n over 1, and 2n, that'll cancel out the n's because the n is the exact same for both sides of the equation. Now we have m1 lambda 1 is equal to m2 lambda 2. And so this next part might be the part where you didn't know what to do next. And if that's the case, don't worry about it. So what we're going to do is let's divide both sides by m2. And we're going to divide both sides as well by lambda 1. And so when we rewrite that, we get m1 over m2 is equal to lambda 2 over lambda 1. Now we know what lambda 2 and lambda 1 are. That's the 500 and the 625. We don't know what the m1 and the m2 are, but this is a ratio that we just solved to say that this ratio is equal to this ratio. So whatever let's say the 625 is 2 and the 500 is 1. So lambda 2 was 625 times 10 to the negative 9 meters divided by 500 times 10 to the negative 9 meters. Since we both have nanometers, we can simplify that down just when we put it into our calculator. So that's going to give us 625 divided by 500 is 1.25. What the heck does that mean, right? Well, if we think of that in a fraction, so let's go second fraction to decimal or decimal to fraction, that gives us 5/4. So this is equal to 5 over 4. What is 5/4? Well, that's equal to m1 over m2. So m1 is 5, or the fifth order of the m, and then m2 is fourth order. And so what is the thinnest film that this can occur for? Okay, so when we come to our equation, we have t is equal to m lambda over 2n. And now let me just double check myself to make sure I didn't say it right. We want M1, which we said was the 5, and M2, which we said is the 4th. Now over here we had lambda 2, so they're across. So the 625 will be with the 4th order and the 500 will be with the 5th order. I think I might have said that backwards earlier. So we're going to use the 4th order M for 625, or 5th if you want to use the 500. And then we'll multiply that by 625 times 10 to the negative 9 meters divided by, let's see, 2. And the N in this case we said is 1.38 for our thin film. So now we have 4 times 600, oops, not 600, 625 times 10 to the negative 9. And that's divided by 2 times 1.38 for the index for the thin film. And that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9. So 906 nanometers, or 10 to the negative 9, is the thinnest film which can occur for this thin film. Now, to illustrate my point, if we go back to our calculator, let's just change these. So we have, instead of the 4th order, whoops, let's get out of here. So instead of the 4th order, we have the 5th order with 500 nanometers, and you'll see that the answer is the exact same because the ratios are the exact same. That's why it doesn't matter which one you get. They will both give you the same thinness of the thin film.